Good morning, and today we are talking about an important property of quadrilaterals. I construct a quadrilateral and I join the midpoints of the sides of this quadrilateral in order, and I want to see the figure formed by joining them. Let me take now say some points, and this is my first point. Here is the second point. Here I have the third point, and now I have the fourth point. And I join these points using line segments, and let me construct a quadrilateral. And this is my first point, and this is my second point, and first point, second point, first point, and the second point. And this is my first point and this is my second point. A quadrilateral is constructed. Now let us mark the midpoints of the sides of this quadrilateral, and I change the color. Now I want the midpoints actually, and to mark the midpoints I should identify the points, end points actually. The first is the second, and the midpoint is marked. This is the first and this is the second. The midpoint is marked. This is the first and this is the second. And finally we are marking the midpoint of the last side. So midpoints of the sides of the quadrilaterals we have marked. Now we are going to join them and to form a quadrilateral, and let me join them using line segments. Here is the point and here is the second point. This is the first point, here is the second point. Here is the first point and here is the second point, and finally this is the quadrilateral we have got. So you can usually see here, no matter what kind of quadrilateral you are considering, the figure formed by joining the midpoints of the sides of a quadrilateral is all the time, it is a parallelogram. Okay, and if you want to know the proof of that, you can join any diagonal, and in that triangle you are joining the midpoints of two sides of a triangle. Eventually that is the that is half of the third side and parallel to that one, and using that theorem we can understand that this figure is every time it is a parallelogram essentially. Let us take a few cases where we take specific quadrilaterals. Suppose you take a rectangle, and when you take a rectangle, the figure formed is essentially a rhombus. Okay, so you can understand that because the diagonals of this rectangle are equal, and therefore you get a rhombus. And the other way around, if you take a rhombus, the figure formed by joining the midpoints of the sides of a rhombus becomes a rectangle. So let us understand how it looks like actually. I am taking a rhombus now, and I am looking for the figure formed by the midpoints of the sides of a rhombus, and now it is a rectangle here. You should have noticed that this is looking like a rectangle. So if you join the midpoints of the sides of a rhombus in order, you get a rectangle. And let me take say a square and see how it looks like actually. I just take a square which approximately looks like a square here, and the proof is of course a trivial, you can understand, but here the figure formed by joining the midpoints of the sides of a square is again a square. Okay, and that is because the square what we have considered here, the diagonals, they bisect each other and they are also perpendicular to each other. Okay, and for that reason the figure formed here this will be a square. So if you want to understand the proof of that, I have offered you a method. Let us say here you have taken a quadrilateral, and I also want to take say join any of the diagonals. Let us understand how it becomes a parallelogram. This is my first point and this is my second point, and you have a triangle here. Okay, and you have a triangle here, and if you take the triangle, we have taken the midpoints of two sides of the triangle, and therefore this must be parallel to this one. Okay, and similarly when you take the other triangle also, and you have taken two midpoints, you have joined them, and this must be half of this diagonal and also parallel to that, and that gives you by transitive property that, and these two sides, okay, of the parallelogram, they are equal and parallel. If a pair of opposite sides are equal and parallel, and that is a conclusive proof to say that it is a parallelogram. Okay, this is how you have to understand when you take a quadrilateral and when you join the midpoints at the sides of a quadrilateral in order, every time you get a parallelogram, and when you specifically take a rectangle you get a rhombus, and when you take a rhombus you get a rectangle, and a square, if you join the midpoints at the sides of a square in order, you get another square. Okay, but to generalize that, if the midpoints of the sides of a quadrilateral are joined in order, you essentially get a parallelogram.